Ngā mihi anō. It's my privilege to present to you a species and take you back to home and talk about a species that we call kanakana. So we'll have a bit of a hikui, a bit of a journey about that. Now, I had a couple names up there as authors, but actually, to be honest, this is a multi-authored talk. This is a journey that I'm talking about, a hikui, and the whānau down south, this is a celebration of what the mahi they have done and an acknowledgement of that. So for the Aotearoa, Wahaupai, Ora Kaparema and Hokanui Runanga, it's a sort of, for me, it's a celebration of a species today, but also the celebration of the people that are connected to that species. And so I've put an overview, because as scientists we like to put an overview, but this is a journey, so yeah, I'm going to talk about kanakana, one of my most favourite species in the world. We are going to bring you home, so for a brief period of time you're travelling to the bottom of the South Island, and give you an overview of our journey, and realising everyone else is in their own journeys as well, so this is just our space, and some future directions and places that we would like to go to. So this beautiful taonga species is called the pouch lamprey, or kanakana, piharau. There's many other names, and at a certain period of time, maybe 20 years ago, whānau would have to put the picture up because they have different names for it. It is the only, so I'm going to have my glasses on, only lamprey species we have in this country. It is, in fact that didn't help, so I won't bother. For scientists, it's really hard to monitor. So that is a story about how whānau have actually helped scientists understand the species more, and whānau have actually really have been the drivers for this species recovery. What else? Yeah, population's decreasing, and again, not hard to monitor for scientists, but whānau know it's been declining. They know their catches, they know the species. And at the moment, there is some protection under the MPS for freshwater management, but that's as it remains as a threatened species. I prefer that these species actually got protected because they are what they are. Now, this has got my science nerd slide. Their life cycle is really complicated. And it is a highlighting, they breed in the freshwater, they go out to sea. So again, they don't care about siloing of our management, that we're dealing with freshwater or coastal. This is a cutie-kitai species, as many of us are. So it starts in its life in freshwater as a filter feeder, so it's sort of filtering all the bits and pieces out of the water column. So it had a really important function there, helping clean up the awa. Living in the sediments, come out at night. So this is a very nocturnal species, very shy. And then about 3 or 4 years, that's what the scientists reckon, they'll turn into a miniature, that changes whole form and develops a little sucking disc. It's a wee tiny thing, goes back out to sea, attaches to fish, so it has a parasitic life cycle. So it's enjoying living on big fish. In some cases, people think they might be on whales as well. Then it comes back into our about 4 or 5 years. Again, that cycle is really unknown, and that's when whānau are targeting them, so when they're fresh run. So they can be this amazing blue colour when they first come in, but as they come into the awa, because you're so delicious, you want to hide, so you want to start looking more like the awa, and so it becomes browner. And after a year and a half, they don't eat in the freshwater. They become ready to spawn. And at the end of this, I hope I've got some videos of within their spawning nests, and this is what whānau have done to help scientists find them as well. So, and they become quite different. So the pouch lamprey, the male, actually has a pouch that no scientists know what that's for. And so I've just put this picture up here just to highlight the sucking disc. And it's very useful, and I have found from personal experience, if you don't tie up your sack or your bucket, isn't got the lid on properly, you will find that they will climb up or your wash house. So they are remarkable climbers, and there are many stories like that. Whānau will know that they're very old. Scientists have found them in their ancestors in the archaeological records about 450 million years ago. The world was quite a different place in that space. So a very ancient species, and very cryptic, and has only let some of its information come out recently to science. And obviously whānau have far better, deeper knowledge of them. So let's take it home. So this is Murihiku, far south, from the Ngai Tahu, on the other side, it's just above where Pio Milford Sound is, and south. So Murihiku is very large. We don't have very many people. It's Ngai Tahu whānui, so it's one iwi authority, one iwi collective, 4 papatupu runanga. Most of our area is in Department of Conservation administered land, so land that we can't access to actually gather kai, and the rest of it is heavily impacted by development and farming. We are outnumbered by regional councils and TAs, which is quite frightening. And part of our life cycle and part of who we are is about travelling up and down to get our resources. So our seasonal calendar is also part of moving up and down. Talk about hikoi. So we also depended on areas like nohonga sites, so seasonal camping sites, to travelling for our kai. So we'd expect resources to be there in situ to support us doing that. And then this, probably not that easy to see, but just showing you that there are different times of seasons. Come off the Titi Island, just start looking for kanakana. Different methods of harvesting as well, and some of them are different methods in the same sites, so we have to acknowledge that whānau would use their different ways. I put the this whanganui picture, but there were pā kanakana in some parts of the Ngai Tahu takiwā as well. And there are certain sites still, there'll be other sites, I haven't put all the sites up, of course, but there are certain sites that are really, really important for harvesting kanakana, the Waikawa, which is in the Catlins, and the Matoda. You'll hear me talk about that too. Even the Oreti, I've caught them there. The Porakino and the Waio River, well known for its fishery, but huge impacts from hydro. And we all know it's really important to practice the harvest, and important to be part of gathering, to physically keep on doing it, and pass it on to the next generations. So our research journey, I think I put it somewhere that was from 2007, but it's been much earlier than that, obviously, because whānau have been observing, and we have had great examples from yesterday about how observations and the science of our whānau. And I can't even see that. 2006, I think it would have been the Matoda Mataitai, the first freshwater mataitai, and that was around kanakana and tuna. So, but a lot of work happened before that in the 90s with scientists to understand some of the movements. The state of takiwā happened as well. So that was a tool that was developed by Ngai Tahu, looking at sort of framework, Kiuji-ki-tai framework to put information in. And one of the rivers was, well, two of the rivers was the Matoda and the Waikawa, both important sites for kanakana. Trying to figure out where else I am. And so there was also monitoring. Whānau got so concerned about their fishery, they did a lot of customary monitoring. So a lot of monitoring and counting on the rocks, writing down all the tohu. So all that observation stuff we heard about yesterday, that's what whānau were doing there as well, and really important. And so that led into getting funding to get a acoustic camera to look and help to just make tell to everyone, yes, this is working, but also helped highlight the species a little bit, because it was particularly important in 2011 we had the situation where we had mass mortalities of kanakana, and tangatiaki from the Matoda rang that up, and we had quite a battle with, initially with MPI to actually get this taken seriously, but they came on board. And so a lot of recognition of that species and a lot of work by whānau to actually see how far it spread, where it was, because scientists couldn't find them. Only people that can find these things and actually monitor them is with their own techniques were the whānau. And so we've moved on doing work using different science tools. So the babies, the larvae, they produce pheromones if it's warm, and so that's a chemical signal. And so you can use science that Niwa has produced that collects that chemical in the water, and then you can send it to a lab, and it can say that maybe there's kanakana up there. And so we have done looking at Waikawa, Porakino, the Waio, and the Matoda. But when we use these tools, we also have to acknowledge they have errors and a non-detect, and it's the same for eDNA when we're using that technology, does not mean it's not there, and it shouldn't be used against whānau who know that fish is there. Okay, so there are limitations to that, but there are lots of other tools you can add to that. And we have been fortunate to do other types of research looking at our monitoring framework, our framework of how do we put information together to assess cultural uses. So we looked at how the thresholds that were required. So we had a program called Ngāki Te Wata Wānanga, and we had a program that actually was able to sort of pilot 3 different uses. So one was wainohoanga, because that's really important to us, waipaunamu, because that for us is a mahinga kai as well, and waituna. And we are working on thinking about moving into a wai kanakana, and that is looking at attributes for the fish, the fishermen, so the people connecting to that particular species, and the ecosystem that supports both. And we have had a habitat bottleneck project, which is we're looking at with a spawning habitat of kanakana, and that's what I'll be showing you very shortly, some videos of that. And I think that's that slide. When looking for locating the habitat of spawning habitat, we use 3 different kind of methods, and whānau were involved in all of this. So they know the awa, they know where they're to find the river, and so they're actually part of the research crew. So we identified, because we went to the Waikawa catchment, it's not the hugest awa, but it is still big for scientists to cope with taking fish and then trying to follow them up the awa. So we used that technology I mentioned about the smells that kanakana make, the pheromones, and we used that. We looked at the catchment and figured out which catchments bring the biggest signal. So it's saying, yep, all the babes are here, come here, this is the best spawning ground here. And so with whānau's permission, they took them off the rocks where they harvest, and they brought them to us, and they were with us. I didn't do it because it requires precision, and I'm like a bull in a china shop, putting little tags in them, just like how you do the cats and dogs, or your cattle. And then it spent the rest of the year and a half going up and down the awa trying to find them and marking where they were. So we can find out where they're hanging out for the year and a half, where they're hanging out, kind of where the risks might be where they're hanging out as well. And eventually we found them. We found some, not all of them, because some would have been eaten by tuna, some by the shags, and some were just too cryptic for us to find, as you would expect. So we found 13 spawning nesting sites in those 3 years. So they're still cryptic, they're still letting us, and they will continue to make us work for finding them. So they were in mostly modified areas, and which is good, they're adaptable, but it's not so good when your farmer has a digger and can dig out some of your nests by accident because they didn't know they were there, and I'm not sure if they would worry about that or not. We did find one in a forestry block, so there were forestry on the top, and the headwaters in there, and there was some evidence that they were reusing their homes, which would make sense. When they breed, kanakana don't survive, they don't have another breeding, but the next couple that comes in and moves in, obviously that home was useful for them. And so there's little dots where we found some, and there's a picture inside the nest. For some reason I put it upside down because the eggs should be the other way up. So they want to put the eggs on the top. And so determining what spawning habitat looks like from the awa, from the bank, is really difficult. There's a whole lot of varieties of where they were. So from really kind of what you'd say more pristine foresty areas to banks that are slipping in very modified catchments. In a way that's good because they're quite adaptable, so that gives you some hope. But it means also that it's really hard to find the spawning habitat by chasing adults. So there is, I'm trying to see if I can see my glasses. So there's good news and bad news. Yes, we can find them. It takes a lot of work. They're adaptable. They are using different places. So the Waikawa, they were in cavities in the bedrock. and actually were sharing their homes with some other fish, so with the bullies and coda, so they were, coexisting, hiding from the tuna. Unfortunately, on the banks, you can't necessarily determine exactly where they are, so it's certainly useful to use other technologies to find babies. But yeah, cryptic, little, and there's a hand there that's showing sort of a hole where we could put a little camera in to actually see them inside the nest. So hopefully, yes, so here we are. In the nest, we found the male and the female, so both of them are there. Both of them are looking after the eggs and the babies. And they have very strong guarding behaviours that you expect. You spend that long time looking after. So this is the male attacking the camera, which I don't blame that, because it was nice and dark and nice and cosy, and we put a camera with a big light on it in there. And so this is the only species of lamprey that has a guarding behaviour. It's the only species that does its little nests in cavities as well. Now this next picture is of a female, and she was really annoyed with us when we were in there. And you'll see what she does at the end of this little video. So you can see they're sort of wrapping themselves around the eggs, and the male and female are doing that. And so those are the eggs that she's moving around. And yeah, she really didn't like us being there, which I can understand. So it's the first sort of recorded behaviour of lamprey spitting at us and throwing a rock. And so you can see as they get older, the mouth bits are sort of degrading and stuff like that. It's just of age. So protecting kanakana habitat, it's really hard to determine where the spawning nests are, but at least we know they're adaptable, because in the other places that they've been found, I think in 2014 or 13, they did work in Okuti, which is in Canterbury in the Banks Peninsula, and they were nesting under big boulders. In the Stye or Styx, I don't even know how to say that river in Canterbury, which is very urbanised. They were actually using modified drains. So the drains, they were box drains, they were actually nesting behind it. So when you're thinking about kanakana and protecting the habitat, it could actually be quite, if they're in their awa, removing some structures may actually be taking away their nests. The best way to find their spawning habitat is probably to follow that smell of the larvae, but recognising that sometimes that detection isn't great. When we did do work in the Matoda, which we would expect them to be pinging all over the place, and it didn't work there. And we also had failures in the Waio River, and so that also caused and the need to look at other techniques, and so actually hitting the banks and the sandy areas where we know the larvae are sitting and lying and living in, and doing a different type of electric fishing technique. So you need to use multiple tools to do that, including knowing from your whānau where you've seen them and those things, all layering all that information together. The best thing for kanakana, because they are highly vulnerable, and you have got a little booklet that Wai Māori has put in your package about how vulnerable some species are to climate change. This is one of them, very highly vulnerable. It's to do what you're doing, protecting your awa, looking after the banks, looking after the riparian margins, those kind of things. And so for our future directions, it's still using those tools that we've got, using our tools, so our frameworks that we have developed about being us, about our cultural landscape, so we've developed some of these tools as well. Using all the different science tools that are useful for us, bringing them into our system and making sure they're appropriate. Also looking at the First Nations in the States. They have done a lot of mahi. They have got some incredible scientists in their communities. They're using genetics, they're translocating the species, they're propagating the species. So there is a whole lot of things that we can use and learn from them. Looking at better ways of drain maintenance. Southland is pretty much farming on wetlands, drainage, It's required for the farming. They are cleaning out streams and rivers that they call drains. So looking at different ways at that, and just continuing with restoration and monitoring and working, whānau doing that for themselves, and they're training themselves to do that. So that's a great story, and the story that I've heard reoccurring from yesterday. And I have gone over time, so I don't know.